Here we begin lesson 13.1 part B. We just got done taking a look at special right triangles, and this is a chart that's in your notes and in your book about what the results were. However, we only showed you how to come up with sine, cosine, and tangent. We did not get into the other three trig functions, but they are just the reciprocals of each. Let's take a look at a question now where it says to find the exact value and then round to the nearest tenth. Now we have three trig functions to work with: sine, cosine, and tangent. We know that they give us 60. With a little bit of work, we'd know that this is 30, so you can look from either angle. But let's say we're going to look from here, and we want a trig function that relates the opposite side from that angle and the hypotenuse. And the trig function that does that is sine. So if we go sine of 60, that is equal to opposite over hypotenuse. So to solve this question for x, we would multiply both sides by 12, and that would give us x equal to 12 times the sine of 60 is approximately 10.4. Now this also asks for the exact value. So we're going to do that with our newfound information in a moment. But first, let's see how we would use our calculator to do the calculation we just did. The first thing is you want to make sure that your mode is in degrees. Right now, my mode, or my unit, is in radians. Since we have degree information, we want to make sure our calculator is also in degree. So now if I want to calculate this, I would go 12 times sine of 60 degrees, and approximately 10.4. Okay? Now, the exact value is found by taking the same problem, but instead of doing 12 times sine of 60, with the calculator calculating sine of 60, we're going to look at what sine of 60 is. Exactly. And the sine of 60 is root 3 over 2. So times root 3 over 2. And this is like 12 over 1, so this would give us x equal to 12 root 3 over 2, which we can simplify that down and get x equal to 6 root 3. Now if you took 6 times root 3, you would get approximately 10.4. But where this represents the approximate answer, this represents the exact. And on ACT tests and so on, they would require the exact answer 99% of the time. Now let's try another one. Here it says we want to find all the sides and all the degree measures. Well, one nice thing is that if we know that this is 28 degrees and this is 90, then it's easily found out that y would be 180 minus the 90 minus the 28, which would give us 62. To find the sides, well, let's say this is side x and this is side y. We have an adjacent side given to us. So let's do cosine of 28 degrees is equal to adjacent over hypotenuse, which we said was y. Now this one can be tricky. I would recommend putting the cosine of 28 over 1 to clarify what needs to be done, and that is to cross multiply. So our solution will be found by taking 11 times 1 and dividing by cosine 28. On our calculators, that would be 11.1 divided by cosine of 28. So 12.57, they say round to the nearest tenth for a side, so 12.6. Alright, so this is equal to 12.6. Now let's do tangent. You could try a couple different ways to do this. This one I like because if I do sine or tangent of 28, I get opposite, the side I'm looking for, over adjacent, the side they gave me. If I chose to use sine, I'd get opposite over hypotenuse, which is 12.6, but what if I did that side wrong? Then 12.6 would cause an error to snowball into another error. So I'm just using the side they gave us as often as I could. Again, put it over 1 and cross multiply. X is found by taking 11 times tan of 28 and divided by 1. So that is going to be equal to 11 times tan of 28, 5.8. So we found out all our sides and all of our angles. Same question, but now we have 3 sides given to us and only 1 angle known. So let's try sine of A is equal to opposite over hypotenuse. How do we find sine A? Well, we do the inverse of both sides. And the sine inverse of sine A and the sine inverse of 9/17, and we get A equal to, and here's how we do our calculator. We go second function sine 9 divided by 17, and that gives us the degree. So they want this round to the nearest degree, so this would be 32. Nice part is, if we know that this is 32 and this is 90, then this would be whatever adds up to 180, and that would be 180 minus 90 minus 32, 58 degrees. For our assignment, a couple of things here. We know that an angle between the horizon or the horizontal line and the line of sight, meaning higher than, is called the angle of elevation. And if we have the horizontal and looking from the line of sight to something lower, it's called the angle of depression. Last question. Here we want to find out the length of L. We're given the altitude, and we're given a degree, which is angle of elevation. We want, from this degree then, we want opposite over hypotenuse. So that means sine will work for us. Sine of 20.2 is equal to 2,900 over the unknown hypotenuse. As before, put it over 1 to see more clearly what we will need to do to solve, and that is to cross multiply. So L will equal 2,900 times 1 divided by the sine of 20.2. So L is equal to 2,900 divided by sine of 20.2. So that gives us 8,398 approximately. And here ends lesson 13.1.